Welcome to the beginning of our series on elementary arithmetic, where we're going to focus on a foundation that you start building in as early as elementary school. We're not too interested in looking for little tricks, little shortcuts to speed up our arithmetic. Instead, we want to build a solid base, a foundation that is sufficient for everyday life. But if you do want to advance beyond that, you have the option to build shortcuts and tricks on top of that. For example, we don't rely on the shortcut that two negatives make a positive. For example, if we have a calculation like this, and we're just in grade 1, starting our journey, we don't want to just rely on the mathematical property that this is equivalent to 2 plus 1, an easier calculation. Instead, we want to have a sense of how these numbers behave, what this subtraction operation requires, what the negative integer is in contrast to positive integers, and not rely on little shortcuts like this. Let's erase this. As we progress, we also want to not think of arithmetic as a sea of options that I have to select from in order to make any kind of progress. For example, if I have 273 plus 99, it's not required that we see this 99 as 100 minus 1. And yes, it is certainly more efficient to then say, let's add the 273 plus the 100 first, and then subtract the 1 later, so that each step is a fairly simple, very simple calculation. We would then get 373 minus 1 for a final answer of 372. Instead, we don't want, in elementary school especially, every student to rely on this choice that they feel they have to make before being able to do anything. We want to build foundational skills, understanding and knowledge to be able to handle any arithmetic that we come across. Also, by having just one method to build on top of, one method in our foundational skill set, we can develop that, practice that, and feel more confident. Instead, what happens, unfortunately, in elementary schools is that they have a sea of little tricks that they have to choose from and select which one to use at which stage. That becomes very overwhelming when your foundation isn't established yet. So that is something to avoid in the early stages. So you are in grade 1, just learning some basic arithmetic with integers, or you're a parent and you have a child that's in that age range and you want to help them, or you're a future elementary school teacher. Regardless, these basic models can be very helpful and a good place to start. So we're going to start with the number line model. Now, I do realize that in most elementary schools, they stick to positive integers. There's no need for that. The negative integers are just different places on the number line. And so for our discussion, we will include them all to give us some variation, some diversity as well. So of course, the integers are positioned in different locations on the number line. We'll mark off a few here, but it goes on in both directions forever. If we have an example and we have a calculation like, let's make it very simple to start with, 3 plus 2, the number line model should be a stepwise procedure to help us read the instructions and get us to an answer without any trickery, without any additional knowledge or anything else. So how does the number line model work? Well, I have to first look at this as a set of instructions. I have 1, 2, and 3 pieces in this instruction line. The first one is going to be instructing me where I should stand in the number line. So in this case, I'm going to stand at the number 3's position. Then I look to the next part of the instruction. It tells me that I'm planning to add. And now, in its most basic, intuitive sense, addition has the aim of increasing, of making more. So I prepare myself by looking in the direction. That was very ugly. Let me just fix that real quick. This is step 2 over here. Oopsie. Come on. There we go. Let's just ignore that. Yeah. By looking in the direction that the instruction wants me to prepare for. So I have these vision rays just to clearly indicate which way I am looking. I'm looking to the higher side on the number line because I'm looking to add. So I'm not really looking ahead yet. I'm interpreting each of these symbols one at a time. Then the third symbol in this list instructs me how to, let's say, step or walk. It says, take 2 steps. So I'm going to take 2 steps forward, and I will arrive at my destination, which then is the answer. So, depending on your background, your level of experience, of course, you might find this to be trivially easy. But do have some perspective that everyone is in a different place in their journey, and at some stage, none of us knew what 3 plus 2 is. But it's certainly helpful to start with something super simple. So in general, I'm going to have these 3 pieces in my procedure according to the number line model. Let's look at another example. I'm just going to delete all of this, like so. Let's look at an example where we include some negative integers. Let's say 3 plus negative 2. Now, I do not want to interpret this negative sign here as a minus. I do not want to use the mathematical property that this is equivalent to 3 minus 2. The number line model makes no such assumptions, no such shortcuts. It uses the instructions as it is and systematically finds the answer. So let's mark some numbers over here. More than enough. And I'm going to follow my number line 3-step procedure. First part says I want to stand at 3. I'm going to look in the direction of, let's say, general addition, wanting to increase. So I'm looking to the higher side. That's what plus wants me to do. So I'm planning to have a bigger answer. However, in this case, I have to add a -2. If I compare that to what I had previously, adding a 2, if it was a 2, I would have stepped 2 steps forward. -2 is the opposite. So relative to how I'm looking, I have to step 2 steps back. That gives me my answer of -1. So it depends, I have to follow this in order. It depends on where I stand, where I look, and how I should step. Now, systematically, as we continue, you can make connections that, oh, if I were to do 3 minus 2, what would that look like? And over time you would realize, or the student would realize, that I would always get the same answer. And then at that stage, we can introduce little connections like, informally speaking, a positive and a negative makes a negative, things like that. But in the beginning, it is very important to not rely on these mathematical shortcuts. Instead, we want to build our number sense correctly. And down the line, when the numbers get bigger, more complicated, and I want to graduate from the number line, though I don't want to draw this every time, then, of course, we need to incorporate these shortcuts. If, in this example, I'm now doing a subtraction, the number line model should still get me to the answer in the same systematic way. So, step 1 is stand where the first number tells me to stand. Now, however, I plan to subtract. I plan to make less, so I'm going to look in the direction of the smaller numbers, which will be the left on the number line. That's step 2. Stand, look, and then step. The step is according to 2, will be 2 positive steps, positive meaning forward, relative to how I'm looking. And I get 1. I just realized that here I wrote a -1 by accident. There was obviously a 1 circled and everything. So we can see, with enough experience in using the number line model, that there certainly are some connections, and one can later on bold some properties, some connections on top of this basic model. Very important that the number line model does not rely on any of these. We can, of course, also start with a negative number, so let's just wrap up with a couple of additional examples. Let's say a -2 plus, I don't know, 4. And let's see how the number line handles that. But the beauty of the number line is that it does not really care. We can list on our number line whichever integers we need. Where's my eraser? And if we feel that, oh, we don't have enough numbers on here, we can always extend this in whichever direction we need to. and visually see the other numbers that are on here. So now we're going to stand at the first number, and its position is over here. We're going to look to the right because I am planning on addition. I then see I need to take 4 steps, 4 positive steps. So I will take 4 steps forward. That leads us to our answer of 2. We can put a circle around it here, and the number line is designed to be getting me to the answer in a repeatable, simple method. Let's do one more, and then we will end our lesson for today. Again, you could be at various places in your journey. You could be a student wanting to use the number line. You could be a teacher of some sort wanting to help teach these very first steps into arithmetic. Let's go with a -2 minus a -1. I simply follow the number line model and not look for shortcuts, not change anything. So I stand at -2. That's the first step. I look to subtract. So I'm going to look to the left. And then I look further into my sequence of instructions. How should I step? Well, I should step according to -1, which will mean 1 step backwards from how I look. And I obtain my answer yet again. Answer is -1. Now, it might seem that the answer is quite obvious. Depending on your experience, it certainly is. The number line is designed to be simple. And with small integers, addition and subtraction is fairly simple. But do keep in mind that everyone is in a different place in their journey. And so what's easy to one person and obvious is not necessarily obvious to another. I don't want to downplay the complexity, which could then make the other person feel quite insecure and actually hold them back in their learning. All right, we will end it here for today. And this is simply the start of our journey into building a foundation for elementary arithmetic. Join me next time where we will talk about the CHIP model. Until then. Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe.